Sorry. It's technical.
All right. Here's the question. Ready? This is saying integrate from B to A. Normally I would write this, the lower number to the higher number. What is the relationship of those two things? Of if I went from B to A versus A to B. No idea? Like if this area, I don't know, Alex, pick a number.
3.
If the integral from A to B is 3, what is the integral from B to A? He says -3. Yes. So why is that? Let's think about it. F of x. Oops. F of x right here is a positive y value. Dx, in this case, was a positive. So positive times positive gave us positive area. This one, going backwards, B to A, that dx was negative. Make sense? So if you think about these as like the geometry of it, the physical, it kind of makes some sense. Okay, losing the edge here, sorry. Okay, integrating from A to A. What's the area under a dot? A dimensionless widthless dot. 0. So the integral from A to A is 0. Believe it or not, they have ways of making that a challenging question. They hide it. Like, oh, it's from A, which is this function, to B, which is that function, and they both came out to be, oh, this is 2, that's 2, so it's going to be 0. If this is a number like 3, I'm allowed to move that number, just a number, outside. You can't move variables outside, and it's disturbing because k looks like a variable, but it's just a number. Number. Sometimes it's easier to integrate with the number inside, sometimes you want it outside. It's up to you. Okay with these so far? And I don't know why, but they make a distinctly different statement for that number being negative. Not any different. We can move the negative in and out of the integral sign. And we can pull the functions apart, or we can squish them together. When it's add or subtract. Multiply? No. Adding and subtracting? Cool. Okay, then there's this one. they're saying if you integrate from A to B and B to C, it's the same as finding the area from A to C. Is that reasonable? Okay. However, they did not tell you that the numbers had to go A, then B, then C. What if C was here and B was there? Does that still work? Let's think about it. Area of A to B is all of this. Area from B to C, is B to C positive or negative? It would be negative in this case because it's going backwards. And we're left with the area from A to C. Does it still work? Yes. So just letting you know that I see these linking up like a chain. As long as those numbers match, you can smush it together. Diagonal match, that is. Cool. You are so quiet today. Already on Thanksgiving break. Guess you gotta make it a whole week. There's days between now and then. Don't know about you, but I'm counting them down to the half days. Yay, rooms for integration. Okay. Franklin, I'm sorry, did you miss something?
I missed the last one.
The last one was linking them up. Good? Okay. So Stella, how about this one? This first one, going from, integrating from A to B, f of x. This is A, that's B. Is the area going to be positive or negative? Finding the area under the curve from A to B of this f of x. Positive, okay? Claire, integrating from B to A. Is it positive? Negative. Ella, integrating g of x, that's the one below, from A to B. A to B, going to g of x.
Positive or negative?
Negative. So the y value was negative, dx was positive, so overall it ends up negative. Emilia, how about this one? From B to A, going this direction, of g of x. Positive. Kinda? Like, I don't always get the story right. Well, if this is your stock price here, your stock price was like losing money the whole time. If you went back in time, you would have had more money then, right? You dug yourself into less of a hole. You guys dislike that one. Okay, so try it. And I'm gonna ask you guys to put your answers on the little boards. You guys on the whiteboard, ooh. Just write down what you got for the first one, and we're gonna compare.
Alright, number one. Two.
Number one, write it
Oh,
down.
wait, no, yes.
So. For 5 groups, I can see you guys said 2. Because if integrating from 1 to 4 is -2, 4 to 1, just change the sign. Okay. That one, write it down.
You have that three?
Okay. Ray, what's, okay. Alan, what'd you guys get? Okay. Roman, what's your group get?
Three.
So those guys link up, -1 to 4, so 5 minus 2, you got 3. Okay. How about that one?
Yeah, I don't think about that. I don't know.
Your most conversation.
Yeah, I didn't know.
What do you get?
Because it would be half of it, yeah, but it could also be some, yeah, so.
That's fine, that's a fine.
Yeah, no, I see.
What do you guys say? Okay. So, I see. So, I don't know. You're right, it's not possible to definitively say. You don't know that it's symmetrical, you don't know that it's like evenly distributed, so you cannot tell. What about this guy? What do you guys get? Here, Evan said it's not possible.
Yeah.
George didn't even change the words. He wrote, or did you erase and put it back? Because what if this was a circle? Going, defined only -1 to 1. What's the area out to -2 and +2? You don't know that it's there. So, all right, number 5, what'd you get?
31.
Claire, did you guys get?
For five?
Yeah. Katie, what'd you guys get?
We haven't gotten them yet.
So I just heard someone say 2 times the f of x from -1 to 1, plus 3 times the h of x from -1 to 1. Yes, that's all you do. Is that a question, or just? What about 6? Amelia, what do you guys have? You got nothing? You don't know? Okay, well, this answer is 2. H of x. I know h of x -1 to 1. Do I know h of x from 1 to 4? No, so not knowing that one piece, you cannot evaluate. You don't know. And on the SATs, that's the hardest one to choose, the cannot determine, like not given enough information. A, it's greater than B, it's less than, C, it's equal, D, not enough information. And the AP exam loves giving you questions that say things like, evaluate if possible. So now that they are stating, like using those words, you guys need to be strong enough, be confident enough in your work to be like, I don't know, and I'm okay with that. And here's why I don't know, you didn't tell me enough information. I need to know the integral of h from 1 to 4. You can get sassy with it if you like, that's fine. Hello. All right. Here's the next thing. Mean value theorem for definite integrals. It's just mean value theorem backwards. Okay, so I have this continuous function, and it looks like this. I always see this as, it's an ice sculpture that when it gets really relaxed and it starts to like melt, it's the height of the water that would end up in the tank. So mean value theorem was, there is somewhere that the average has to equal the instant. Here is my average, and here's the instant where it was equal. The next page is full of like the formula, but just getting you into the idea. Yeah? People are writing out. Oh, and I didn't tell you guys, did I? Tomorrow, there's an exit card on Delta Map that is, it was on the list, I just didn't do it yet. So it's on the LRAM, RRAM, MRAM business trapezoid rule. You can use a calculator, you can use the calculator that's on Delta Map, I don't care. Yeah.
So it's like the homework you gave us on Delta.
Yeah. So like, find the area, approximating using one of those 4 methods. And if one of the sides is 0, don't do an extra one because you feel bad for it. And knowing if it's an over or under approximation and why. Okay? Right. So here's what mean value theorem for definite intervals means. It is also known as the average value of a function. So again, on the previous page, the integral is the area under the curve. And this is, if all the water melted, it's the rectangle that would result. What is the height of that rectangle? Or what is the x value where it hits that height? And that's all just to say it's the average value of the function. So if you were, that function was temperature, that's how you would calculate the average temperature. So if you do not know how to integrate from other classes, use your calculator for this, but find the average value over the interval. So just, can you crank through the process? Can you write down what the equation is and try it? When you guys get an answer and agree on what your group answer is, put it on the board, or on your little whiteboard, that is.
Yeah, I got the same thing. You just write the answer.
So, someone has a non-decimal answer. Ooh, a number of people have non-decimal answers. How do you have non-decimal answers? Your calculator gives you square roots? So they're saying the average is 1, and, okay, let's look. Don't panic, those of you who don't know how to integrate yet, it's coming tomorrow. But undoing power rule, raise the power divided by the new power. So, raising the power from x to the 0 to x to the 1, dividing by the new power of 1. Oh, okay. Raise the power from 2 to 3, and then divide by the 3. And the cool thing about integration, you can check yourself by doing the derivative. And then this whole thing is fundamental theorem of calculus. There are 2 rules for that, and your book calls them 1 and 2. I've seen other books that call our first one, their second one, whatever, doesn't matter. Then it's fundamental. We're gonna hit that hard because last year's free response questions on the AP exam, 4 questions were on fundamental theorem of calculus. Which might be why that list is so long, because again, the name is fundamental. I thought that would be key and important, so we do that a lot in here. Before the free response questions being on this, they did very well. Okay. So where's the average? Equal. So the average was 1, and what is the x value where that happens? Right at about √3. And that's saying if the water level is the red is area under the curve. And if this high stuff in the red leveled off, the height of the water would be where the green is, which is the height of 1. And square root of 3 is where that, I keep not being on 10, where that average happens. Kind of, sort of. Faces like roar. Loving this. Yeah. Believe this is one of the homework problems. I don't. What'd you get? What'd you get? Evan, what'd you get?
I got average value of 1, x equals √2.
So what'd you do?
Sorry, average value is 0, not 1. But it's still x equals
So how do we find the average value?
0.033, and then multiply that by 1.
No, you don't have to write the 0 here. you do need to write it there. Those who know how to integrate, Jason, what's the integral of x squared? X to the third over 3. Who else has physics? What's the integral of -1? Negative x. Raise the power from x to the 0 to x to the 1, divide by the 1. And then this weird, can't say it because it's recorded, but, okay. We're gonna do this tomorrow, especially. Once we actually do the process of integrating, that curly Q bar from the left becomes a straight bar on the right. And the straight bar, I've used that in the past to say, okay, dy dx evaluated at x equals 1 and get something. We are now going to evaluate this at these numbers. How do I evaluate? Well, I'm gonna plug this number, the top number in first, square root of 3 cubed. And now plugging in the bottom number, subtract and plug in the bottom number. And I did something wrong. Because I end up with 0?
That's one.
That's right, okay. So the average value is 0, and at what point does the function equal that? So when does this function equal 0? Why do both answers not work?
It's not in the domain.
It's not in, so the negative answer isn't in there. This is another new wrinkle with BC Calc, AP in general. They don't want you to give answers outside of the range. You're like, oh, well, it works for these 3 things. I only want the one that's in the feasibility window. All right. How y'all doing? Yeah, I hear ya. I have carried your papers back and forth from home. I've graded 8 of them. 8. This many. Some of y'all were chatty people. Okay. Not there. Oh, this is what happens when you have student aides do your slides. He's integrating the school, get it? Yeah, okay, all right, whatever. So this is the homework, part of the homework. This is just problem 1 from the homework, but hold on, let's see.